Hi, Professor.
Hello, Hassan. How are you today?
Okay, I guess.
Okay, I guess.
I tried I tried the practice exams like without any help yesterday, and I just sat there confused and lost.
Uh-oh. Uh-oh, we got to get
Yeah, that's
past
a
that. Yeah, that's why we're
yeah,
here.
definitely, definitely.
So, are there any
So
particular ones you want to start with?
so I want to do nomenclature because I need to practice that.
Okay,
Can we do like one that'd be like a test question, something
sure.
like you might give us?
Yeah. How about on fall 20? Let's see. I'm looking around here. Wow, a lot of courses here. Here we go. Fall 20 nomenclature test 1. Let's bring it on over and take a look at it. Here we are, fall 20. Test 1. Do one for the evening. It should be opening up. There it is. Sharing screen. So here we have the whole test. Looking for part 3. Why don't we just take it from the top? We can grab the whole thing and just do parts. Here we go. And bring it on over here. Pins on. Fall 20. Fall 20. T1. There we go. So we're supposed to draw structures for the following. 6 Tert Hexel undecane. Huh. Where does one even start with that? Any suggestions? Anybody?
Start drawing the main chain.
That's
Yes. Excellent.
the
Excellent. So how many carbons are in that main chain?
11.
11.
11. See? And then we stick figures are nice and go 1, 2, 4, 6, 8, 10, and one more. I always verify. I'm never sure where I started and stopped my sticks. I'll count from the bottom. Odd numbers. 1, 3, 5, 7, 9, 11. Good. All right. And now on carbon 6, I have to draw a Tert Hexel. So here's 2, 4, 6. There's some kind of group up here. What's your strategy for drawing a Tert Hexel? How many carbons are in the longest chain of the Tert Hexel? Don't say 6.
4.
4. And we had a very young student agree there. 1, 2, 3, 4. And where are the last 2 carbons?
On the other side.
By that, do you mean on the other side of the first carbon?
Yes, from the carbon that
Yes.
that is branched.
Yes, the one that's attached to the chain is carbon 1 of the hexyl group. So yeah, we have to put 2 methyls on there to make it a tert. Remember, every tert ever has this minimum. Every tert ever has to have that as like its base. And then if you need 6 carbons in the circle, there's 4. You have to add 2 more. If it was tert octal, we'd add 4 more. 1, 2, 3, 4. That would be tert octal. Let's get rid of all that extra stuff now. So there you go. That was a good start. And now we're going to try this next one. They get progressively worth more points, don't they? Yeah, B's worth 2 points. So we got a stereocenter. I like stereocenters. So once again, don't start with anything in the beginning. Go all the way to the end and draw nonane. So we'll do this one in blue. We'll do it right here. 9 carbons, right? 2, 4, 6, 8, 9. And on carbon 4, there's groups. See, 4, there's a cyclopropyl, and on 4, there's a bromomethyl. Once again, methyl's what's attached, bromo's on the methyl. Cyclopropyl. How do you draw a cyclopropyl?
A triangle.
Yes, you draw a triangle. Now be careful how you do that. Once again, off carbon 4, we're going to draw the cyclopropyl. I don't worry about wedges and dashes till I figure out my R and S. Now don't draw the triangle like this. I've seen this hundreds of times and they've lost points every one of those times. They say, oh, I just draw a triangle like you said. You drew a cyclobutyl. You want me to count to 4? Watch where that is attached here. That's a carbon. 1, 2, 3, 4. You didn't draw a cyclopropyl. You drew a cyclobutyl. So make sure the end of the stick right here is one of the corners of the triangle. There. So you got 3 carbons. 1, 2, 3, cyclopropyl. Also on carbon 4 is another group. It's a methyl. I just drew a methyl. What else does the methyl have on it? A bromo. How come it doesn't tell me where the bromo is attached to the methyl? Like other groups, like down here, I had to say the propyl is attached to carbon 2 of an octyl group. Well, here, I didn't need this parentheses because there's only really one way to attach a bromo to a methyl, and that's right here. And it's a BR. And we don't need the parentheses. It's not wrong to put those parentheses. It's not wrong. It's just not necessary either. Okay. And now you got 1.25 out of 2 points for the blue. We can do better than that. We have to do an R stereocenter. So to do that, first you do your priorities. 1, 2, 3, 4. A carbon with a bromine has a higher priority than a carbon with 2 carbons. It has a higher priority than a carbon with 1 carbon. Has a higher priority than a carbon with 1 carbon. Wait, that doesn't make sense. This has the highest priority because the heaviest atom attached is a Br. That's the heaviest atom on any of these 4 carbons. This has a higher priority than the other 2 because there's a tie for the first bond to carbon. Tie, tie, tie. And this second bond to carbon, there's no second bond to carbon here. It's an H. H loses to the second bond to carbon. Same story here. Why does 3 beat 4? Well, it's CH2 once, twice, 3 times. CH2 once, twice, 3 times. After the third CH2, it's another H. After the third CH2 here, 1, 2, 3, it's a C. C here beats an H that's out here. And that's why we have those numbers. And guys, when you connect 1 and 2 and 3, it's already clockwise. What's my strategy for making sure the stereocenter is S when the direction of that arrow is the right direction for this question? You put the 4 on what kind of a bond? Wedge or dash? I need somebody to help.
Dash.
Thank you. And you pick an adjacent bond for the wedge. It doesn't matter here, as long as it's adjacent to the dash. And there you go, you got your 2 points. Nomenclature to me is like lab work. You do a lot of work, you spend a lot of time, and you don't get a lot of points. But you can't talk about organic chemistry without it either. So it's not the most important thing, but without it, you can't do anything. Does that make any sense? It doesn't really, but you've got to learn it. It's like learning how to talk. I mean, you can't be an English major if you haven't learned how to talk yet, right? Okay, a lot of talk. Wow, we got this monster here. It's got bicyclo 632 tridecane at the end. How do I always start my bicyclos? I start by drawing 2 dots. Let's have this one wander over here. Start by drawing 2 dots. Horizontal, vertical, I don't care. How about a hybrid? 2 dots. The 6 means there's 6 carbons between those dots? I'm going to put them in the middle. 1, 2, 3, 4, 5, 6. Make sure there are 6 carbons between the dots. 1, 2, 3, 4, 5, 6. Good. The 3 means there's 3 carbons between the dots. 1, 2, 3. The 2 means there's 2 carbons between the dots. 1, 2. There you go. You got half a point for that out of 4. Now we start putting stuff on it. On carbon 8, there's an isohexyl. So where's 8? Well, you got to pick one of the dots to be 1. Doesn't matter. And when you go to 2, it has to be in the biggest bridge first. So that has to be 2. And that takes you to 8 here. On 8, there's an isohexyl. What's our strategy for doing an isohexyl? How many carbons in a row in an isohexyl? Don't say 6. How many in a row for isohexyl?
5.
5. That's right. 1 less because there's a 6th carbon that's a branch. 1, 2, 3, 4, 5. Make sure you drew 5. 1, 2, 3, 4, 5. Good. And to get the 6, where do you put the 6th one? Do you put it on the first one? Answer no. Do you put it on the next one? Heck no. Heck no. Heck no. Oh, yes. You need a V on the end to be an iso. And now you've got 6 carbons. You get the 5 in a row and the 6th one off the second last one. And then on carbon 1, we're going to draw an octal. Always draw the end part first. Octal. 1, 2, 3, 4, 5, 6, 7, 8. Verify. 1, 3, 5, 7, 8. Off carbon 2, there's a propyl. This is carbon 1. The one attached is 1. The one away is a propyl. 1, 2, 3. My blue arrow needs to move a little. My blue arrow needs to move a little. There. And keep in mind, carbon 2 is now a stereocenter, and it needs to be R. Yeah, the stereocenter is in the group. So please, every time you have a stereocenter that has an H, I need the H. This is the only time it's mandatory to put an H when it's on a stereocenter. Do your magic of 1, 2, 3, 4. And you're either lucky or unlucky. Either way doesn't matter. This one, I'm going to save you a little time by doing the work a little quicker than you're probably ready for. That's a 1 because it hits a branch early. This is a 2 because it's part of a longer chain. These are both chain groups. That's it. So you can look at the length of the chain. And there's a 4. I connect them and it's counterclockwise. Oh, don't cry. Do not cry. It's counterclockwise, which would, if I put the 4 on a dash, that means it's going to be S and you're going to get it wrong. So what do you put the 4 on? Instead of a dash, I gave the answer by mistake just there. It's a wedge.
A wedge.
Thank you. And pick an adjacent bond for the dash. You want it to be this one? Nice. So we took care of that stereocenter. Stereocenter on 1 needs to be S. That's a whole new ball game. Let's put it in hot pink. Now this one is number 1 for the stereo. We're not talking about the stereocenter in the green group anymore. We're talking about this stereocenter here that is 1. So up here, this is also the 1 up there. It's a CH2 that goes to a branched carbon. This here is a CH2 that goes to not a branched carbon, but the next one's branched. And this one hits a branch on the 4th carbon, and this one doesn't hit a branch for 100 years. I exaggerate a lot. It hits a branch on the 8th carbon. 1, 2, 3, 4, 5, 6, 7th carbon. But that hit a branch much earlier. The branch is what beats the non-branch CH2s. Are we lucky on this one? 1, 2, 3 is counterclockwise. Stereocenter on 1 is supposed to be S. The number 4 group is going on a dash.
Sir,
Yes.
I'm struggling with this thing.
This method.
Yes.
This trick? Well, it's a trick that works every time. You do the 1, 2, 3. If it's the direction that the question demands, they put the 4 on a dash. If it gives the direction that's the opposite of which the question demands, you put the 4 on a wedge, and that covers every Stereocenter ever. So you can do it other ways. It's going to take more time for me to grade it, but I'm going to grade them. Trust me. If you're making me do double switches, I do the double switches. You'll see them right on your graded exam. Don't forget, you're not finished with the Stereocenter. You just did a dash. I need a wedge. You do the wedge here or here. It has to be adjacent to the dash. Just looks like there's a little less drawing to do if I put the wedge here. But you might still have some questions about my technique.
Yes, just one question.
Go ahead.
Okay, you said that number 1, we number the carbon number 1 because it has the greatest mass.
No. There's a 4-way
Yes.
tie. 4-way tie. CH2 with a carbon ties CH2 with a carbon ties CH2 with a carbon ties CH2 with a carbon. You've got to go, what's the next heaviest atom? The carbon. It's comparing this carbon now to the second carbon here, to the second carbon here, to the second carbon here. They're all CH2s except for this one, which is a CH with 2 C's. So I'm comparing a CH2, the same distance from the stereocenter here, as this C with 1 H here. So the bond from this C to a C ties the bond from this C to the next C. Now go back, the bond from this C to this C beats the bond to this H. That's why we have a winner up there for 1. Once again, don't start with these videos. Start with the videos where nomenclature is being introduced, because it does a lot of examples with R and S. And the textbook does a lot of examples too. I go fast in these videos because I'm assuming you've watched the other ones. Well, let's do 8 and see what happens there, because it's supposed to be R. And it's a 4-way tie with carbons again. We'll do 8 in purple, which these are just CH2s, starting for the first 2 carbons on all of them. But the CH2 after this CH2, it's a C with nothing but bonds to C. After this second CH2 here, it's a C with only 1 bond to C and 2 H's. So those H's lose to these other bonds to C. Same story here, CH2 once, CH2 twice, CH2 once, CH2 twice, then a C branched, then a C not branched, means the carbon here ties one of these branched carbons. Now I got to compare an H to another of these branched carbons, and H is lighter than carbon. So it's not about mass of the group, it's about mass of the heaviest atom attached at the same distance away. It's a lot of words. So what we have here in carbon 8, we'll do our stereocenter in purple. We have a 1. And then this one hits a branch earlier than, now let's see, I believe this branch here is earlier than through the middle. 1, 2, 3, and the 4th carbon is branched. So that 4th carbon is going to beat the 4th carbon here. 1, 2, 3, 4. I'll explain why again. Let's do the full Monty, as they say. Look at the 4th carbon away here and compare it to the 4th carbon away, 1, 2, 3, 4, here. We have a tie for the heaviest atom attached. We always ask, what's the heaviest atom attached? There's a tie. Go back to the carbon we're comparing. What is the next heaviest atom attached? You can't use that. You've already used it. It's an H. What's the next heaviest atom attached here? It's this C. We're comparing this purple H to this purple C, which is heavier. Purple C, which makes this the 3. Makes this the 3, and this the 4. And we connect 1, 2, and 3, and it goes clockwise on carbon 8, and it's supposed to. Therefore, the number 4 group's going on a dash. And an adjacent bond gets the wedge. This is adjacent. You put the wedge there, or you could have put the wedge there. All right, and that's as hard as our nomenclature gets on test 1. It's not impossible. With practice, you'll be there. And then you want to do these guys too? Make it a good,
Yeah.
complete session. All right, now parentheses are your enemy in nomenclature. First job. Let's do it step by step here. I'm going to snip my snip. I'm going to grab this guy. Do it step by step. All right, get rid of the parentheses and remember what they mean. The 3 means there's 3 CH3s attached where? Well, they can't be to the previous carbon like this one says. These propyl groups, both of them are attached to the previous carbon. Well, if the parentheses start the molecule, they can't be to the previous carbon. They got to be to the next carbon. So when I crossed the 3 off, I got rid of how many methyls? Don't say 3. I still have this one here, it's drawn, right? It's bonded there. You got rid of 2. So I'm just putting them back on as sticks. I'm going to get rid of the whole deal here. There's 2 propyls sticking off here. 1, 2, 3, 1, 2, 3. And this, don't cross this off. You know what CH2 in parentheses means, I hope. If not, there's a video I made with nobody around because I knew it was going to be a problem when you look at tonight's problem set. And yes, it'll be later tonight that you get your first chance to look at the problem set. I don't know what time yet. It will be tonight. And there's a video that says what to do with these things. And there's 5 CH2s in a chain. It's in the chain that starts here and then continues here. 5 CH2s in the middle. So I'm just going to leave that there. And when I do the nomenclature counting of the chain, I'm going to say, okay, if this was carbon 6, then that would be, I got my fingers, 7, 8, 9, 10, 11. Yeah. 12, 13, or whatever it ends up being. Don't get rid of those parentheses, but get rid of this. There's 2 methyls off the previous carbon. Take that off. That means you got rid of 1, and I put it back on there. Now I can find the longest chain and number it the correct way. And somebody tell me why I chose left to right in this example and not right to left. It's a good question, by the way. Now, guys, when that's the first one in there, 7, what's the 5th one? A lot of people want to say 12. You forgot when you're counting inclusively, it doesn't go like that. I got my 5 hands, 7, 8, 9, 10, 11. Inclusive counting. The difference is 1 less than 5. And then that was 12 and 13. Ew. How did we say a 13 carbon chain? I wrote a U by mistake, didn't I? I have no idea why I wrote a U. Tri. Oh, that's why. No, I don't know why. Tridecane is the only way to say 13. Okay. Now we have groups. We have methyl groups. How many methyls are in this molecule? Remember, if it doesn't have a number on it right now, then it's a single carbon group. It's a methyl. So how many methyls does this molecule have?
3.
3. How do you say 2 of them are on 2 and 1 of them's on 12?
2,2-dimethyl.
Careful.
12-methyl.
Careful.
Oh,
They
2,
all, yes.
2,12.
Yes.
Trimethyl.
That's it. You nailed it. And there's a reason why I'm leaving a little room after it. Because alphabetically, that doesn't go by T, it goes by M, right? M. And I've noticed my molecule has propyls. You see those 2 propyls here? And propyl goes after methyl. In fact, I don't think I left myself enough room. So how do you say 2 propyls on 5? I think she knows the answer. That's easier than the methyl one, isn't it?
5
Yeah,
dipropyl.
nice. And notice she didn't say 5-dipropyl. That would be wrong. No, you're not allowed to. If you have two groups identical, you must have two numbers in front. If you have three groups identical, you must have three numbers in front. And you had a question.
Why didn't you put carbon number 6 with those that are inside the parentheses from 7 to 11?
Oh no, that's part of the chain. And oh yeah, we are done. Sorry.
You
Sorry.
could have
Why
done like
those aren't
CH2
those aren't groups. Those are chain. Notice when we have a big long chain here, these are all CH2s. CH2 1, 2, 3, 4. In fact, as a good practice question, and it's talking directly related to what we're doing here. Why don't we, as an exercise, convert this to a typed version right now? Let's do that. Typed and condensed as possible, left to right. On the end, you have a CH3. How many CH2s follow? We have 1, 2, 3, 4. And there's a C with an H, right? 1H down here. And the short form for this group is, it's a group, parentheses, C with two CH3s. Yeah, that's a parentheses within a parentheses. It's terribly drawn. I'll fix that. And then CH2, CH2, CH3. And I hope I can get rid of this ugly parenthesis. Yes. This might be a time to use like a square parentheses versus another one. So yeah, that's a C with two CH3s. There's a C with two CH3s. And then a CH2, CH2, CH3. I could have gone CH2 twice as well, right? And then we got to finish the chain. CH2 once, twice, 3 times, 4 times. So that is the same as that. You weren't asked for this, by the way. And we got the first one done. And B. Now B. What do we do with B? Can you tell me how the name ends for B?
1, 2, 3, 4, 5, 6, 7, 8. It's cyclooctane.
Nice. It's a cyclooctane. How often do you get to see two O's beside each other when it doesn't make an ooh sound? I'm sorry, that kind of stuff fascinates me. Cyclooctane is no, it's cyclooctane. There's a group on 1 and a group on 2, 3, 4, 5. And what's the name of this group on 1? It's a single carbon group. So you know it's what's the name of a single carbon group always?
Iso.
Methyl.
No. A single carbon group is a methyl. Do not let the pattern of the V trick you. This is not a CH3 here. This is not a CH3 here. This is not an iso group at all. It's a 1 carbon group with 2 iodines on it. So it's a diiodomethyl group. Not unlike the bromomethyl group here. There's a methyl with a bromo. Here's a methyl with 2 iodos. So cyclooctane's getting moved over. If it lets, oh, you're not going to let me do it. It's got on carbon 1 a diiodomethyl. IO is before IS, isn't it? 1 di. Oh, it's my favorite thing again. 2 I's in a row. And what's that group on 5? Can I squeeze it in there? You see, there's your true V pattern because those are all carbons, right? So you can start with iso and then count the carbons total and give me its name. How many carbons you got there? That is a big eraser.
Isopentyl.
Yes, isopentyl. Can I squeeze it in? Yes. And you got 1.25 out of 2. Oh, no. Is it about stereocenters? Or is it about cis and trans? Sometimes it's about both. But I purposefully did this example because this is, can you tell me why that's not a stereocenter? What's the definition of a stereocenter? There's only one. If you're talking about carbon stereocenters, it's a carbon with
Attached to four.
four different groups.
Oh, it's
Well,
not a title.
it's yeah, because they're different groups, they will have 4 different priorities, but this thing does not have 4 different groups, so it does not have 4 priorities. Even when you count the H, which is here, right? There's an H. I'm not going to draw it. I know there's an H there. There's only 3 bonds showing. So let me count the groups. There's an H, a diiodomethyl, and a CH2, 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 C branched. Well, CH2, 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 C branched is the same as CH2, 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 C branched. They are identical. Notice there's 3 CH2s, then the same branched carbon. It's 3 CH2s, then the same branched carbon. You can't tell me this group's any different than this group because they're not. But you can tell me that these 2 groups are on the same side of the ring by using what little prefix in front? Somebody said it.
Cis.
Yes. Oh, my pen turned off. I talk too much, my pen turns off. Cis. Yep, that's worth 3/4 of a point for knowing that they're cis when they're on the same side. And then we got this little beast down here. Let's snip him too. We're having a big first segment here. 2C. Looks like a little Pac-Man. You guys even know what Pac-Man is anymore? Oh, where'd it go? I gotta turn my lights on. We're getting dark in East Point. And I'm putting dots everywhere. There we go. All right. Question number 1. It's a bicyclo. I hope you see that. And the dots are here. Let's make some big dots. Here, here, and here. Those are the dots. And which one should be number 1? Does it matter? In my mind, it really doesn't matter because they both put if that's the one, then the next group's on 2, 3, 4, 5, 6, 7, 8, 9. And if this is the one, then the next group's on 1, 2, 3, 4, 5, 6, 7, 8, 9 again. They both have group on 1, group on 9. There's not a better way or a worse way unless I teach a rule that I don't want to teach. So let's just decide right now that we'll call this 1. And that has to be 2. Why does that have to be 2? And this would be a mistake to call this 2. Why is that a mistake? Because that's a smaller bridge. That's why. Sorry, you were going to answer, weren't you? 2, 3, 4, 5, 6, 7, 8, 9. So in my bicyclo numbering, I know there's going to be a 7. What? How do you do that? Well, how many carbons are between 1 and 9 without counting 1 and 9? 7. How many carbons are between 1 and 9 going this way? 1, 2, 3, 4. And how many carbons are between 1 and 9 going the smallest way? 1, 2. And then you add the numbers and the 2 dots. 13 for the numbers and 2 dots is 15 pentadecane. All All right. And then you got to give me the two groups and the two stereo centers. 3 stereo centers. One of the groups has a stereo center. My goodness. All right, we're going to be busy. I'm going to get at least one light on the. I'm working in the dark here. Okay. Let's do the stereo center on 1. We'll do it in green. There's CH2s once, twice, C branched. CH2 once, twice, C. Oh, doesn't matter about branching here. Let's compare this C, which is how many from the stereo center? 1, 2, 3. Third C from the stereo center here versus 1, 2, third C from the stereo center here. I have one simple question comparing these two Cs. What's the heaviest atom attached to this C? A fluorine. What's the heaviest atom attached to this C? A carbon. Which of those two atoms is heavier, fluorine or carbon? Fluorine. That makes this group attached here, number 1, and this group that hit the branch, number 2. This group that hits a branch earlier than this group, 3. And this one that doesn't hit a branch till the 9th carbon, 4. The 2 doesn't go there. 2 goes where it's attached. There. And oh no, the 4 is not on a wedge. The 4 is not on a dash either. We don't have a quick way to do that stereo center. If you have gifted abilities at observing objects in your mind and are able to rotate them, please do so and connect 1, 2, and 3 with a 4 sticking away from you. I have no idea what you just did because I don't have those abilities. I have to do a double switch because it's a trick I learned that works 100% of the time. Double switch, once again, you copy the tetrahedron. Do not move any bonds. That's where the limit of my abilities is. Find the 4 right here, switch it with whatever's on the dash. In this example, it's a 2. Now your 4 is on a dash, and the 2 goes where the 4 was. That's a single switch. You've got to do 2 switches to get back to the original stereo center. Switch the 1 and the 3. 1's up here now, 3 is here. Stereo center on carbon 1 is R. If you connect 1, 2, and 3 there, it is clockwise. Okay. We still have work to do on we have one more stereo center in the rings, and then we have a stereo center in the group. Let's do the stereo center in the ring. Yes.
So for the double switch, does it, the ones that you switch, do they have to be like the same? If that makes, like, is it always going to be like the 2 and the 4?
Absolutely not. 25% of the time you're switching the 4 with a 2. 25% of the time you're switching the 4 with a 1. 33% would be the answer. 33% of the time you're switching the 4 with a 3. You switch the 4 with whatever is currently on the dash. You can have any number on the dash, correct? Hey, if it's number 4 already, you're not doing a double switch. Okay?
Oh, okay.
All right. So the double switch method says find the 4, switch it with whatever group is currently on the dash. Notice when those words I just used, did I use a number for whatever group is currently on the dash? I did not. There's a reason, because that could be number 2, could be number 1, could be number 3. In this example, it's number 2. The 4 switched with the 2. And you better switch the other 2. They happen to be 1 and 3. So the 1 goes where the 3 was. There it is. The 3 goes where the 1 was. There it is. And now you can connect 1, 2, and 3, keeping in mind this stereo center is identical to the original because you did 2 switches. And whatever you get here means that's what it was here. And that means you don't have to go and put your eyeball here and look from the bottom here with the molecule above your head and then connect 1, 2, and 3. That gives me a headache just even trying to describe it. I mean, some people can do it. My ex-wife could do that. Didn't have to do a double switch ever. Gifted woman. Okay. If you go into dentistry, you have to almost have that ability because you're using mirrors inside people's mouths and you don't want to poke holes in their cheeks. Anyway, Stereocenter 9. Where's the 1 this time? I think it's the one going inside the ring. Stereocenter 9 is going to be baby blue. There's CH2s all the way around. You want to see them? CH2, 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 CH2. This one hits another CH2, then a branched carbon. The others all hit CH2, then an unbranched carbon. CH2, then an unbranched carbon. CH2, then an unbranched carbon. So the 1 is clear. The 2 is a little tricky. Which one of this? We're comparing carbons that have just C's and H's. So now you can talk about branching. Which one hits a branch earlier? 1, 2, 3, 4. Then the 5th one's branched. 1, 2, 3, 4. Oh, the 4th one's branched. 1, 2, 3, 4th one's not branched. So I know my 2. And this one doesn't hit a branch for a long, long time. And this one does. And you caught a break on this one. The 4 is on a dash. This is a straightforward stereocenter. Counterclockwise gives S. 9 is S. And what are the 2 groups? This is a 3-carbon group. That's called a propyl with fluorines on the 3rd carbon of the group. So how do I say that? And this is a 1, 2, 3, 4, 5, 6, 7. That's a heptyl with a group on the 5th carbon, 5th, 6th, no, the 4th carbon. 1, 2, 3, 4th carbon. Ethyl on the 4th carbon of heptyl. That goes alphabetically under E. How come? It's a good question. There's I leave room a little bit. 4 ethyl heptyl. Why did I have to leave a little room? Because it's got a stereocenter in the group. We'll do that stereocenter in a bit. I'm going to cross my fingers that it'll let me move all of this. Oh, I'm so lucky. Because I have another group that goes by the letter F. Shall we do the stereocenter or should we name the other group? Let's name the other group. It's on carbon 1. Carbon 1. Oh, I didn't say where this group was attached. Where is that group attached? What carbon has this 4-ethyl heptyl group? There's the 4-ethyl heptyl. It's attached to carbon 9. 9 goes here. 1 goes here. All right, and that group on this one is a propyl with fluorines on it. I still didn't move things far enough. Yeah, nomenclature's tricky. Tedious. None of the rules are hard, they're just annoying. It's a 3,3 difluoro. Still don't have enough room. Propyl. There's the parenthesis. Okay, so it continues here and then down to there. And stereocenter here, without much further ado, because we've had this segment last about an hour. No, we started at 5:15. That's a 4. That's a 3. This is a 2. That's a 1. It's an R stereocenter in the group. Not to be confused with the R stereocenter on carbon 1. Sadly, I did them both in green. Anyway, I'll let you digest that when we come back. You think of some good questions for when we come back. It'll be a bit because that was a rather long segment.